Hello everyone. In this session, I'll be explaining about three important memory mapped I/O registers, which are PINSEL0, PINSEL1 and PINSEL2. Okay, we will understand why they are required and what exactly they do. As you can see here, this is nothing but the pin out diagram of LPC2148. Okay, you can see there are total 64 physical pins or physical legs of the IC, and the functionality of each pin is specified in this particular diagram. If you notice here, some pins might offer single functionality, as you can notice here, while some other pins offer multiple functionalities through a single pin. In order to make sure that one particular pin is capable of providing multiple functions, we need these registers. The registers we are discussing here are nothing but normal memory addresses itself. Okay, now when you say pin select 0, there is specific address associated with it. That is, it is associated with the address 0x E002C 000. What it means is you can use normal load store instructions to access this particular memory address, but based on whatever value you write at this particular address, the functionalities of the hardware will get affected. That is what you mean by memory mapped IO registers. Okay, they act as a normal memory address where you can load and store some information, but that information will affect the functionality of the hardware. If I consider this particular IC, totally it has 64 pins, as you can notice here. To make sure one particular pin is able to provide multiple functions, we should use certain registers which can control and determine what exact function is to be performed by it at a particular instant of time. Out of these 64 pins, only 48 can be controlled by those registers, while the remaining 16 pins are other essential pins for the hardware which cannot be controlled, like for example this VDD, VSS, etc. Okay, so let's ignore those 16 pins and focus on the remaining 48 pins which can be controlled. And before we move into the next slide with more details, these 48 pins which can be controlled are grouped into two ports, that is port 0 and port 1. Okay, port is nothing but collection of pins. See, these are the registers about which we had to learn. Pin select 0, pin select 1, pin select 2. The actual full form of pin select is nothing but pin function select register. Okay, as you can understand by the name itself, we are using these registers to determine what exact task is to be performed by that particular pin of that particular port. Okay, and one more thing you should know is pin select 0 is used to control port 0 pin number 0 to 15, that is the first 16 pins. Pin select 1 is used to control port 0 pin number 16 to 31, that is the next 16 pins. And finally pin select 2 is used to control port 1 16 pins. That is the total 48 pins which can possibly be controlled. Let us try to know more about pin select 0 register so that we'll get one general idea about how exactly we can use these registers to control specific pins of specific ports. All these registers specified here are 32-bit registers. 2 bits of these registers are used to control one pin. Okay, you will understand this further in the next slide. If you consider this particular table, this is nothing but your pin name, that is P0 stands for port 0, and the number after the dot indicates which exact pin are we speaking about. Okay, so if you notice here, what this particular row means is To determine the exact function to be carried out by port 0, pin number 0, we use the bits 1 and 0 of pin select 0. Okay, that is, if you consider this to be your register 0 to 31 bit positions. If you consider the first two locations, that is bit 0 and bit 1, the value stored in this two location determines what exact task is to be performed by port 0 pin number 0. That is, see, if there are only 2 bit positions allowed, what are the combinations of bits that are possible? They are 0 0, 0 1, 1 0 and 1 1. Each of this bit combination will represent different functions. Like, let's consider the first case only. Based on what value is set in the first two bits of pin select 0, port 0 pin number 0 can perform these four functions. That is, if I store a value 0 0 here, doesn't matter what I write in the above locations, if a value 0 0 is stored in pin select 0 bit 1 and 0, immediately port 0 pin number 0 will start acting like a GPIO port. What is GPIO? General purpose input output. Okay, but instead of 0 0, if I write something like 0 1, then immediately the functionality of that pin will change. It will start acting like the transmit data pin of UART 0. Okay, at the same time, if I change this particular data to 1 0, then it will start acting like pulse width modulation output 1. Okay, while 1 1 is a reserved option. Okay, so based on what exact value you choose in pin select register, here we are speaking about port 0 pin number 0 to 15, so because of which we are considering pin select 0 register. If you wanted to modify the functionality of the other port pins, then you had to select other pin select register. Okay, so based on what exact values are chosen, as you can easily see and understand here, the functionality of specific port pins are determined. Okay. If you continue checking here, the second and third bit is used to control port 0 pin number 1. Okay, and these are the different functionalities it can hold. Okay, so by making minor changes, that is just by changing the values in pin select register, we can make a single pin. Okay, that is, for example, pin port 0 pin number 0 or port 0 pin number 1, or all these pins are specified here to perform 4 different functions. Okay, so that's all about pin function select register.